Welcome, folks. This is Vivek. You can see me there. I am the co-founder and chief data scientist with CellStrat. So we have a platform called CellStrat Hub, which allows you to simplify the process of learning, developing, and deploying AI. So let's get started with that. And I'm going to invite our product development lead, Bhavesh Ladagiri, to present this workshop today on how to deploy Vision AI model on our platform. So Bhavesh, over to you.
Thank you. So hi everyone, good morning, and I'm Bhavesh Ladagiri, and I'm an AI product lead with CellStrat as mentioned. And let me just share my screen and we can get started with this workshop. And just let me know if my audio and my screen are completely visible.
Yes, all good so far.
Yeah, okay. Yeah, so this is a workshop on CellStrat Hub API, basically deploying a model as a serverless API using CellStrat Hub in very few steps. So this is actually a second part of the series. So the first part was where we deployed an NLP model. So this time we'll be deploying a vision-based model. So all of the sessions are standalone, so there's no prerequisite or anything. So it's not so it's not required. So if you haven't attended the first session, that's completely fine. So so let's first start with what is CellStrat Hub API. So I see there are many new faces. So let me just explain what CellStrat Hub is and what the API is. So CellStrat Hub is a development and deployment platform. So it provides cloud in servers or cloud virtual machines for Jupyter Lab. So you can run your code in dedicated virtual machines in Jupyter Lab, and you have many other features to go along with it, like you can collaborate in real time with other users to code together. You can even run graphical user base GUI based applications like simulators and all as well. Like usually in any other notebook based platforms, you are not able to do that, but here we do have the facility to run simulators and all of that as well, and you get dedicated storage. And so there are also GPU and CPU tiers. The CPU tier is currently free. So CellStrat Hub API is basically another part. So that development part is called workspace, and the API part is for deployment. So in the API part, you can actually deploy a model in under 15 minutes, provided you have all your code ready. And there are no format requirements as such. Usually when we go to deployment, there are, like if you go to, let's just say, SageMaker, you have a specific format in the way that you have to deploy it. So, and if you go to deploying any transform based models on Hugging Face, then also you have you have to port your model to the transformers library. But here we don't have any strict format requirements. It's just whatever you bring your own model and deploy it without any hassle. And every API, every model is deployed as serverless. That means that you only pay for the number of invocations. Because unlike because in other traditional methods, you would basically have a server that is running 24/7 to listen to your API calls, right? So that's expensive because you always have to pay for that. But because this is only for the number of invocations, it's quite cheap, and also it's free actually. So technically you don't even have to pay anything. So it's free for the first 1,000 calls. And all of the APIs have auto scaling, so you don't have to worry about the traffic and all. And in general, everything is deployed using Docker. So if you want to get more complete control over your execution environment, like maybe optimize your OS or anything like that, you can always use Docker, the Docker image. You can always modify that to get it to your standards if you want to use it. And so generally for free, you can deploy a maximum of 5 APIs. And overall, you will have 1,000 API calls free every month. So if you have any questions on Hub API, you can ask in general or throughout this session. This someone having a...
So I'm checking Trishti's account. You go ahead. I'm checking Trishti's account.
Okay. Yes, so today we'll actually be deploying the clip model for zero-shot image classification. So last time we deployed a zero-shot text classifier using a natural language inference model. Yeah, so basically we repurposed a model which was trained on natural language inference and made it for text classification. If you don't know about that, that's fine. The thing today that we are going to do is we're going to do something similar. We are going to do zero-shot prediction, but for images instead this time. So Clip is a model by OpenAI. So it's, I guess, recently, a few months back only, it was released. And it's basically a pre-trained model, which was pre-trained to align text with um, which was pre-trained to align text with an image. So what they did is they scraped all of the internet to get the images and their captions. So generally, if you go to Google, if you Google images and if you search for image, you get an image, you'll always notice a caption also or a title of that image or something along those lines. So what they did is they created a data set based on that. So they fetched all of the images and their associated sentences and created a model which will basically align the image to the text. So we have the image and we have a image text, and both of them are based on transformers. So the text goes through a transformers as well as the image also goes through a transformer, and you basically get some vectors, and you basically align it in such a manner such that the diagonal is always equal. So because we want this image and the associated caption or the text description of that image to be equal, right? So this diagonal will always be like it is trained such that this diagonal is always one or like the closest. So 0 means no similarity, 1 means highest similarity. So yeah, so this is a pre-trained model. So it was pre-trained like this in this format. And after that, what was done is what you can do is to make zero-shot image classification is you can basically take an image and basically have a bunch of text labels for it. So let's say I want to classify this as a dog, and I have total of 4 classes. So plane, car, dog, and bird. So if I, but again, also these are just words, so I can actually kind of convert them into a sentence by mentioning a photo of. So yeah, so that way I can do that.
No,
And
so in the pre-training, exactly what we did, we took the internet, web scraped data, images along with text, and you created correlated feature metrics, right? Where text and
yes,
image pairings are learned. So once text and
yes,
images pairings are learned, then you can use that feature set for additional inference on the right side, right?
yes,
Okay.
yes, essentially, yes. So yeah, so after pre-training, if you want to like use it for zero shot prediction or anything, what we can simply do is the idea is you take a bunch of sentences or just a bunch of words and put into sentences in this particular format. Let's say just so because the model was trained on sentences, right? So it's better if we frame it as a sentence. So as a sentence, and then align the image and check the similarity of this particular sentence with this particular image, and whichever one is the most similar is basically that's the class that we had that is the predicted class. So here in this example, you can see plane, car, dog, and bird. So all of these go through the model's text encoder. So there are two encoders, right? So the image and the text. So the model's text encoder, we'll get some vectors, and we'll also put our image through an image vector. And when we check the similarity of this image with every piece of text here, we'll find that the text containing dog is the most similar one. So this is how generally we can basically repurpose Clip for zero-shot prediction. And it's not only for just for image classification, you can also use Clip for essentially like OCR kind of stuff as well. Maybe not that as accurate, but without any training. And in general, you can also use it for moderation and any kind of so basically the general idea is you can find the similarity between image and text, and then you can repurpose it for any task. So even people have used Clip for image generation. So they use this as a discriminator or kind of thing. So it basically tells whether the generated image for the given text is good or not, or like high similarity or not. So there are a lot of applications for Clip.
Hi, Bhavesh.
Does
It's
anyone have any
Rahul.
questions? Yeah, hi.
Yeah, Pavesh, this is Krishna here. One quick question on pre-training model.
Hmm.
You said that
Sorry, your audio is
diagonally
not clear.
is almost made as one. The others are right. Okay. Let
Hello.
me. Is it better now or
It's
is
breaking.
it
It's
better?
quite cracky.
Now it
It's
looks
breaking
okay,
still.
Or if,
Krishna.
Okay.
Go ahead.
yeah, now it's fine, I think.
No, it's okay. Yeah, yeah. The question I have a question on the pre-training model. You mentioned the diagonal is almost equal to one or near one. The others are near zeros.
Hmm.
So how is that
Yes,
achieved actually?
not necessarily near zeros. Not necessarily like basically when we are pre-training this, we will have like a set of labels as well, right? For this when like automatically generated labels. Okay. So this is our, so we take our image vectors and we align them together into this square
Hmm.
diagonal matrix. And we'll also have a set of
Right.
labels for the same. So we'll have a set unit matrix for it. So 111 and then all the zeros others. So during pre-training, what will happen is we have our image and text vectors. We'll get some similarity, right? Generally, when we do a dot product, it essentially gives us a similarity metric without even using any cosine distance or anything. But I guess in the paper they did use cosine distance. But nonetheless, so we do get these values, some distance values between this vector and let's say this vector, we get some distance value here. But overall, when we are training it, so this is like
Mhm.
our model's prediction, and then we match it with this diagonal matrix of ones to make it so that the vectors are generated in such a manner that this particular images vector and this particular text vectors will always equal to one, or at least closer to one. At least that's what is being tried to achieve.
So it is
That's the general
supervised
gist
learning.
of it.
It is supervised
Okay.
learning. The correct label for
Huh.
that image is
Yeah,
available.
kind of supervised, but this is not like manually generated supervision. It's like just automatically because you already have the image and text pair, so you are just creating this diagonal matrix from it to
Mhm.
kind of create virtual tables kind of thing. I hope that
Okay.
makes it clear.
Yeah, yeah, yeah. Thank you. Yeah.
Okay. Yeah, so anyone else has any other questions regarding what is clip and how we are using it for zero shot prediction? If not, we can move over to the deployment side.
Yeah, the primary discussion today is on the hands-on deployment workshop, not so much on the algorithm itself. But that said, the algorithm is one of the most state-of-the-art from OpenAI Foundation. This clip is a state-of-the-art computer vision classifier from OpenAI, but we won't spend a lot of time on the algo itself. Our objective is to get to the hands-on deployment part of the solution.
Yep. So yeah, so let's start with first building the model, or it's kind of like a bring your own model. So let's start with the hands-on part. So if you have created an account on CellStrat Hub, on your first login, it should look something like this. So you'll have your dashboard and you have the start workspace button and you have a bunch of metrics here. So if you're on the free tier, you will have, I guess, about 15 hours per month or something. So generally you will see how much you have used for that particular month and when it is going to renew or get changed. And you also see your storage and you also see your billing cycle and other stuff. And we do have expansion packs as well. These are like ready-made projects that you can just add to your uh, workspace storage so that you can just learn stuff. Like let's say you want to learn reinforcement learning or hands-on, so you can get a bunch of projects in that domain. You can just click on add more packs to get any of those packs. And yeah, and you also have there's also a bunch of documentation here for different tasks. So on your first login, you just click on start workspace and this should take up to 2 minutes at max for your workspace to be started. So Yeah, so meanwhile, you can also go to deploy models here, which will be basically your Hub API dashboard kind of thing, where we can see your API calls and the number of API deployments that you have deployed. So depending on the tier that you are in, can change. Also, this is an open beta, so still things are subject to change. And you should also see a default API key for you in this something like this, which says enabled and all models allowed. And also you can create additional API keys for permission control purposes if you want. And you will see your deployed models here if they are, but generally if you don't, you will probably see a pop-up saying deploy your first model. And yeah, and we do appreciate any feedback or anything that you want to report to us regarding this deployment. So yeah, let's just wait for it to get started.
So those who joined later, please create an account on cellstrathub.com. That's where we are doing this hands-on workshop. The link is shared in chat, please.
Yeah, so once it has started, the status of the workspace should be running and you should see a launch Jupyter Lab button here. So just click on that and open up. Also, once you're done using it, do make sure that you stop your workspace because otherwise it will consume your monthly compute hours. And let me know in the chat if you want me to wait or anything, if your instance is starting and you want me to wait before I proceed or anything. So, or you can even unmute and speak either way.
So after we launch the Jupyter Notebook, we have to stop the workspace?
No, not now, right? Not now. Generally, I was saying like after you're done using it.
Okay.
I mean, after you're done using this, overall at the end of the workshop, you can click on stop workspace.
Okay.
Bhavesh, can you quickly go from beginning again? A lot
Yeah.
of new people who joined.
Yeah.
So
So
folks,
this
watch
is
carefully what we are doing.
so this is your workspace.
No, go from
So
home
like when
page.
Acha homepage, okay. So you are so this is the main website of CellStrat Hub, and you should see all the features and other stuff. Overall, you should, if you're new to this platform, you can click on sign up and create yourself an account. And you can basically your email and username just for public profile, which can be changed later. So it's not like a fixed username. And you can sign up and it will send an OTP to your email and you can just verify your account. And once that is done, you can click on sign in, sign out. And yeah, on sign in, you can just enter your email, the account email that you used to sign up, and then click on sign in, which should open up your console. So in this console, or it before you like originally, it should actually look something like this. Just go to my other alt account and show you how it looks. So originally it should look something like this. So you should see you are probably on the free tier and you should see the number of hours that you have used and when it's going to renew and some other things like storage used. And you should see the green button called start workspace and you should see your status as stopped here. So when you log in for the first time, you can click on start workspace and this should take about 2 minutes or something to start up. And once it has started, you should be able to, you should see the workspace status as running instead of stopped. And the button should turn red and you should see a launch Jupyter button here. So yeah, so you can just click on start workspace and it should turn to pending. So it will just wait for 1 or 2 seconds and it will turn to pending. And so it will be something like this. So when you click on it, it kind of loads like this and it turns to pending. And yeah, so this can take about 2 minutes. And once it has turned to pending, it should look something like this. It should look something like this. So it should look like a red button saying stop workspace instead of start workspace, and you should see the workspace status is running. And once that is done, you can click on Launch Jupyter Lab, which will basically open up a new window, new tab with the Cloud Jupyter Lab. So what this essentially is doing is this workspace is doing is we are providing a cloud instance or a cloud virtual machine for Jupyter Lab, which is like you can think of it like your own personal laptop in the cloud. Just give me a second.
Yeah, kindly mute yourself unless you have a question to ask.
It's the status says data recovery. So it takes some.
Yeah. So if you have been inactive for a long time, your data would have gone to cold storage, and it probably is recovering the data.
Okay.
I think it
And you
takes
mentioned
about 3 minutes to recover, right, Bhavesh?
Yeah, approximately, I guess.
It goes to S3, Krishna, so it recovers from S3 storage.
Okay. Yeah, thanks, Vivek.
Any other questions?
Yeah, and if you're ready and if your Jupyter Lab has opened up, just put a yes or ready or something in the chat so I know.
So Radha, you have to start the workspace before launch Jupyter Lab will be enabled.
Yeah, Tata, please click on, you should see a green button here saying start workspace. So click on that before clicking on launch Jupyter Lab.
Please send a yes if you are able to reach the dashboard and launch the Jupyter Lab. Please send a yes. Okay, most people seem to be fine.
Just sorry for 1 second. Just give me one.
So yeah. So data recovery status, Krishna. So let's see, in a few minutes it should recover. Maybe
Okay.
5
Yeah.
minutes.
Sure. Yeah.
This is a relatively new feature. So we had
I
added
see.
that we will back up to snapshot, EC2 snapshot and S3 if you are not active on the platform for a while. So then we have a recovery mechanism once you log in again. It should work. We have tested it.
Okay.
Vivexa, can you go to DynamoDB and change the status to in service, just so at least by the time it can recover in the background while the workshop is being done. So
Krishna,
Bhavesh,
can you
it
send me
just
an
came.
email?
It
It
just
came.
came
Achha,
in. It just
it
came.
came.
So Krishna, how
It came.
long it
Yeah.
took to
Oh,
recover?
About 4 to 5 minutes it took.
Okay. So and you had a couple of packs there, Python, MLDL, I assume, right? Or other packs also you had.
So last time we had deployed the model. That is there, I think.
So some of these packs are heavy, a lot of code. That's why I think it took 4 or 5 minutes.
Okay.
So that's okay. I think that's expected.
Expected.
So
Okay.
it basically successfully recovered your data from S3 storage.
Okay. Okay.
So Akanshu, we recommend you check out the which pack we have to add more packs, Bhavesh, for this workshop.
For this workshop, you don't need to add any packs, so I'll send the code.
Okay. So Akanshu, you can check out Python and machine learning pack just to have them there before you start the workspace. But for this workshop, we don't need any of those packs really. I hope everybody is able to reach Jupyter Lab. Any questions, let us know now before we move forward.
I'll just put a GitHub, the source code for this workshop in the chat. So this is the source code for today's workshop, and we'll be importing it in Jupyter Lab in our workspace here. So yeah, so the way we are going to actually import this is on the top left sidebar or whatever, file manager. So this is called the file manager. If you're new to Jupyter Lab, this is the file manager where you can see all your files and folders and all. And clicking on this big blue button opens up this launcher. So where you can either create a new notebook or create a new Python file, markdown file, text file, terminal, those sort of things. And you can also see your running sessions, if any, here. And you will also see a Git extension here and some other things. And there are some code snippets where you can say some other things. But apart from that, yeah, so basically the main thing that you should know is that this is the file manager. You can click this to create a new folder. You can even right click and click on new folder, new file or anything. And you can upload your files with this, or you can just drag and drop either way. And this is just a refresh file list. And this is the one that we are going to use. So this is a Git clone button. So if you have used GitHub before, you probably already know Git clone is basically cloning the repository to your local system. So we'll be doing that. So just click on this button here. So there is this button called Git clone. So just click on this and paste this particular URL here. Then click on clone. Has everyone able to, and you should see a successfully cloned thing here.
But
And
Bhavesh, don't
on
we
the
have to create a SSH login into
no,
that?
like because we are not you're not pushing any of the code to this repository, it's not required. It's
So
only
for
the
polling, you
clones.
don't need, huh?
Huh.
Okay.
Only if you need to push something or those sort of things.
Okay, got it.
So you should see the Zero-Shot Image Classifier deployment folder here created.
So
And
any GitHub repo can be cloned here, huh? Just by that
yeah, any
URL.
GitHub repo, just by the URL.
Okay.
As long as it's public. If it's private, then you'll have to do SSH to get the authentication.
But folks, you still have to mind your 8 GB space, right? There is a 8 GB storage in the free tier account. So you don't want to pull too much code because you'll run out of 8 GB storage space on CellStrat Hub free tier. You'll have to then upgrade to alpha or beta tier, which are chargeable tiers, but the free tier is 8 GB of storage.
Bhavesh, I have created the API last time, so shall I again do this?
Yeah, so that was a different API. So this is a different
Different
going to be
one.
API. Also, that API is probably not visible because if you want it, I can make it visible, but we changed a few things. So it is probably like if you go to deploy models, you will probably not see that API here anymore. But it is still there. If you want access to it, you can still call it.
Right. It's not
those
there.
things. Yeah, but
It's still there.
there's a few updates to the
I can still see
in
that
your
actually
code.
it's there.
Yeah, so the source code and all of that will still be there. I mean the deployed calling. You can still call it and all, but you just won't see it on the dashboard. That's the only thing.
I'm saying it's in the
Like the
dashboard, I can see that.
Acha,
When I
okay.
go to deploy models, if I click, I can see that the existing one.
Okay, that's funny. I guess that
Bhavesh, I
should.
think Krishna recovered from S3, so somehow his deployed models came back.
Maybe, yeah.
But that actually that's unrelated to that. I don't think that. But also although what you can try doing is you can just click on this, click on cookies, and just clear all your cookies here, and click on done.
Sorry, where to click that cookies here?
On the top in your browser, you should see some kind of icon, some lock icon or something.
Okay.
And you should
Okay.
see cookies here. Just click on that, and there will be a few. Just click on remove, and then done. And then just refresh your page, and it should sign out, and then you can sign in again and see.
Oh, okay. You want me to again sign in and sign out?
Yeah.
So
After
Krishna, I
clearing
think
cookies.
it's your cookie. That's what Bhavesh is suspecting. It's your cookie showing that it should not be there.
Okay. Okay.
Yeah. So
There's a question here by Ravi. Can you repeat how to bring the code from
yeah.
Git to here?
Yeah. So there is a button here. 1, 2, 3, 4, fifth button here on the top, or you can even use the Git tab and click on clone a repository. Either way, if you click on it, it should basically open this thing, and you just paste the link of the repo here, and you should click on this clone button. So I'll just stay on the screen, so you know. So this button to this button. Is that clear, or should I repeat it again?
The
Just repeat
Git
it once more.
the Git link is being sent again here in chat. Just check the
Yeah,
chat.
I'll just.
Bhavesh,
Yeah.
see, I cleared the cookies. Now that Git link icon is disabled for me. That Git clone link.
You should come back to your root. You will probably already in the previous link, I guess. You're probably already in the previous folder, right? You're probably in the Zero-Shot Text Classifier folder, I'm suspecting. Right, just click on this folder icon to come back to the root, and then click on this.
Sir, click which one you are saying? The root,
this icon.
Okay,
You just go back to the root home folder or whatever. And then click on this, because if you're already in a Git repository, then you can't clone it, right? So because cloning inside a clone repository, so you're probably already in the previous workshop's Git repository.
Okay. So the previous workshops one also is appearing for me.
Yeah, that has nothing to do with today's workshop. So you can, it's a completely new thing.
Okay. Yeah, thanks.
Okay, can everyone just put a yes in the chat if you're ready, if you've cloned the repository and you're ready with here. So just open up that folder, and you should see a bunch of files and folders here. Actually do one thing, go open up this folder and go to model source, model_src folder. And you should open up this clip.ipynb notebook. Just put a yes, okay. So I have quite a few, I guess. And also once you open this notebook, in Workspace or Jupyter Lab, there's a concept called kernels. So kernels is basically like your virtual Conda environments, where you have, in each Conda environment, you basically have different set of libraries installed. So for this workshop, this is in PyTorch. So we want you to switch to PyTorch. So on the top right, you should see Python 3 written here. Just click on it, and in the select kernel, switch to PyTorch 1.9 and click on select. And then this, so while this is in this energy bolt, thunderbolt icon sort of thing, it means it's loading. So everyone switch, open the clip notebook in model source. So Zero-Shot Classifier, model source, the clip notebook, and change your kernel to PyTorch 1.9. And once that is done, you can just, we'll just install the OpenAI clip library or clip module. So just start running the first cell and the second cell. You can actually run, in fact, almost all of the cells until this point. So until deployment, so you'll have two sections here, right? So there will be a development and deployment section. Just the development part, you can run these cells in the development side. No, actually not these cells yet. You still have to run one command here. If you have any questions or if I'm going fast, just let me know. So just first run these two cells. After running these first two cells, you should see this. I hope everyone is seeing this cell, this markdown cell saying W. On Linux, you can use wget in the command to download the pre-trained model. So because pre-trained models are large in size, you can't put them in GitHub directly. So that's why I put a link in here to download it. So this is the official link to download the pre-trained model. So just copy this thing and click on plus, or actually don't click on plus, go to Git and click on Open Git repository in terminal. Git, open Git repository in terminal. And
Why
that
are
should
we
open
doing
a
this
terminal.
again? Why are we doing this?
We want to download the model, right? So we have to download it from the terminal. We have the link to download it, but we have to somehow download
But
it.
we just downloaded the Git repo, no?
But it doesn't contain the pre-trained model.
Oh,
actually, you can actually do one thing. Don't go to the terminal. Just paste this extra cell here, actually, below this. I don't know why I put that there. And it should download it. I'll just, yeah, cell 3 will give an error. Before cell 3, just run this command that I put there in the chat, which is also mentioned here. Just open up a new cell. So you can open a new cell by clicking a plus icon here or just clicking B. So clicking B would also open up a new cell in the below the current cell. So just paste this and run that cell. So exclamation mark and then wget and then the URL. And that should download your pre-trained model and you should see vitb.32.pt. So it's basically a VIT model, essentially the image encoder part, and the patch size is 32 and it's a base VIT based model, which was pre-trained in the clip format. So clip is like a pre-training method. It's not really a model as such. So I'll just, so this.
Till what cell are we running?
Just first, after you download it, then you can run it till before the deployment part, till here. So only the development section. So generally you can use this arrows too.
We can do
you can run pre-process. If the model has been loaded, you can run pre-process, load sample data, those sort of things, all of those things you can run.
Till deployment we can run, right?
Just before deployment, before just deployment header, you can run.
Okay.
I guess you can also run till the inference script, I guess these 3 lines as well, but nothing apart after this. So this thing's nothing. So don't run this test deploy API yet. So apart from that, every other code cell you can if you want to. Let me just repeat it. Go to the folder model source, open up clip notebook and change the kernel to PyTorch. And once it is done, run the first cell. So running the first cell will install clip, then run the second cell. And just before you run the third cell, add another cell. So you can add another cell with this plus button here, or you can hit the A or B. You can actually just click on this and then hit B to kind of open a new cell below. And so you see this command here, right? So just run this command and prefix it with an exclamation mark and then run this. So this, what this will do is it will download your model here. So essentially this is actually a terminal command, but we can run terminal commands also in notebooks using an exclamation marks as a prefix. But for pip
Changing to
install and all of
PyTorch
those things,
kernel
you
can
don't
be
need
done by
to.
clicking on Python 3 on top right.
Yes,
On-
yes.
Click on Python 3 on top right, change it to Python 1.9 kernel.
The wget command is whatever is there in the comment. Same command, right?
Yes, yeah, same command. Just put that, but just prefix it with an exclamation mark while running in the cell.
Okay, okay.
So I'm not getting any image path problem, Kirtana, so not sure it was working fine.
I don't think it's the image path error. I think she means the model download part. So I think she probably has done it. Now, I hope you have run this cell, right? Yes. Yeah. So just put a yes in the chat if you have downloaded the model and you're able to run the next cell. So run this cell, run the pre-process cell, run the load sample data cell, run the classes, run the predict, run this cell. And yeah, you can also run these cells if you want to. Doesn't matter. And you should see this warning can is fine. You can just run it again. It will go away. Yeah, so these, so I hope you're able to run these cells. Why do we need to switch to PyTorch and run the coded work till deployment? Actually, you probably wouldn't have been able to run this because Torch is not on PyTorch. It requires if you like, you can kind of, I guess this might have like when you are running installing clip, it might have installed PyTorch as a prerequisite, maybe. So maybe that's why it ran. But it would have taken longer and if you didn't use PyTorch.
So can you please tell me that whether the clip is a model? You just told it's not a model, then
Clip
it can.
is kind of, yeah, okay. So clip, you can like roughly, you can like, or generally like when speaking to someone, you can say clip is a model. But technically in the sense, it's basically using a VIT for the image encoder and training it in this particular fashion. So that I mentioned here, right? So this particular contrastive pre-training is done using that architecture. So the architecture itself is the clip. The model architecture is kind of like a combination of a VIT and a regular transformers for the text part. Overall, you can say clip is a model, but the individual parts of it are not new. That's what I meant. Like the image encoder is a vision transformer, a VIT.
I mean, clip is a feature detector, right? It's a feature detector.
It's a multi-model model. You can think of it as it's the individual models are not new, but it's like multiple models have been combined. So there are two particular models here. So one an image model and a text model, both combined together. So clip, yes, you can kind of say clip is a model just in regular conversation, but technically it's a pre-training mechanism. Because you pre-train two different models together in this particular manner. So yeah.
It's similar to
Okay,
ResNet
it's
or
similar to test and
BGG16.
strain like we did in previous split that we trained them.
So sorry.
No, Ronajit is not test and train split. See what happens in deep learning. We have some, cookie cutter models ready. So then we just do incremental learning or inference on some cookie cutter model. So you can say enablers. It's an enabling model which allows us to develop final solutions. So in computer vision, we have ResNet and VGG16 feature detector neural network architectures. So they are used like a pre-trained models for incremental machine learning or incremental inference. So it's like that. It's a feature detector model which can then be used to create further applications.
Okay.
Yeah, there is actually a TensorFlow version, but not the official one. The official one is in PyTorch. OpenAI, I guess it has been, I guess, 1 year or 2 years, I guess, since it has made PyTorch its official framework of choice. Yeah, so the official version is in PyTorch only. But there are unofficial TensorFlow versions definitely there. So yeah, so I hope you were able to all run the cells. So just run all of the cells along with this extra cell, and I'll just explain what's going on. So essentially, clip.load is not anything fancy. It's just basically loading this PT model directly. So we set JIT is equal to true because this model is actually a torch script model. So if you don't know what torch script is, in simple words, it's just like an optimized version of a PyTorch model. So in TensorFlow, you might have seen HDF5 format, right? So in Keras, you save your models at HDF5. So that's a training kind of model. But you also, after that format, you also have a PB format. I don't know if you have seen that format, but in TensorFlow, there's also a PB format, which is like a more optimized version for inference purpose only. So similarly, this JIT true is basically, it stands for just in time. Basically will load a compiled torch script model. So it's generally Python is not compiled, right? It's interpreted. But this will basically load a compiled model, which is more optimized for inference and faster. So that is that. But in general, don't need to get into the depths of that for now. Just know that it's because we can cover that in any future session of optimizing models. But generally, we are just loading our model, and then we have a pre-process function. So this clip.load actually provides the direct pre-processing also. So if you just look at what transformations is, it's basically a torch.compose. So if you've used PyTorch before, you know that in Torch Vision there is a compose where you can combine different augmentations. So we resize it, we center crop it, we convert the image to RGB, and we normalize it and convert it to tensor. So these things. So it's just the compose. Even without this, you can actually, even without clip.load, you can actually load all of these models yourselves without using the clip.load. Is just a utility to kind of do it together. And also because this is a CPU, we specify the device as CPU. And even if you don't, it will automatically load it in CPU anyway. But yeah. So basically, because we are going to encode both the text and the image in our pre-process, what we'll do is we'll take an image and we'll take a the list of classes, and then we'll use transformations to convert the image into a vector, and we'll also use the clip.tokenize feature to tokenize the classes into a vector. And then we'll basically load some sample data. So we have, if you go to the images folder, you should see there's a bunch of images. So we have, I guess, 5 images, one of some people dancing, some kids playing, maybe one with Elon Musk in a mask, a plane, and some traffic. Yeah.
So Bhavesh, we are not doing any trainings. We are only doing pure inference, right?
Pure inference. Yeah, so I'm just basically in this notebook, I'm just explaining how the model, how we are using it even for prediction or inference. So just step by step notebook manner. So let's say we have 5 classes here: kids playing, dancing, Elon Musk wearing a mask, aeroplane, and traffic. So yeah, and then so what we'll actually do is we'll actually append that a photo of. So if you remember, I said that because these are just words, it's better to frame it as a sentence, right? So we can like prefix all of our words with a photo of to kind of put it in a sentence. So that's why we just have a small lambda map function. Yeah. But overall, the main thing is this: the predict function. What this will do is we'll take our image and our classes, and we'll first pre-process them using our pre-process function. Then we'll put a forward pass. So just take a model and give our image, our processed, our vector, image tensor and classes tensor in here. And we'll get logits per image and per text. Don't get confused, it's just a transpose of each other. Logits per image means for each image we'll have, so for if we can actually do multiple image inference as well. So for now we're just doing one, so where you can have, let's say, 10 images and 5 classes, and it will basically, the images will be the rows and the classes will be the columns. Logits per text is the opposite way around, where your images are the columns and your text is the rows. We don't need this thing as of now. We just need this logits per image. We'll take that, and these are all cosine distances. So this model, what this is actually doing is it is basically encoding the image and the text and doing a cosine similarity between those vectors. So it's not really any linear head or anything. just the cosine similarity between the vectors. And and to make it human readable, we can actually pass this through a softmax. So just so we can convert it to probabilities. And then we just format it. So format it in the sense in this particular format. So a list of tuples. So in each tuple, we'll have the name of the class and the probability of that. The name of the class and the probability of that. Name of the class, the probability of that. So that sort of thing. If you multiply it by 100, you will get the percentage probability, of course. Yeah, but this is what is. So it's pretty straightforward. We pre-process. So there are only 2 steps in this particular model to make inference. We pre-process it, and then we put it through a model. We'll get our logits per image, and we use softmax over it to kind of to normalize it, and so that's more human readable. And then we get this. Generally, cosine distances are between 0 and 1. And 0 means least similar, 1 means most similar. So when we are applying softmax, we are essentially turning it into probabilities, like whichever one is the most similar image. So for this particular text, so a photo of dancing, the dancing.jpg image is 88% similar, like after putting through softmax normalized value. So or that's basically our prediction confidence. So this is it.
Alex, one
But
question
apart
here.
from, yeah.
Sorry, it is actually finding the cosine distance between what? The query image and the other images it has
the
in
image
database.
and the text. No, it doesn't have a database or anything. It will just take this image, put it through an image encoder. So we have our image encoder here, right? So image encoder is essentially a vision transformer here. And we'll take each of those texts. So we have 5 text here, right? Kids playing, dancing, Elon Musk wearing a face mask, aeroplane, traffic. So we have these 5 text. So we are comparing that image with all of these 5 texts, and whichever one is the most similar is our prediction. So in this case, it is dancing. So clip is essentially like a image to text similarity model. So it will compare. It will tell whether a piece of text and a piece of or an image are both similar or not. So that's what is different. So essentially, zero shot in the sense that we are not training any of this as an image classification. Without training itself, we are able to predict them because it is so good at similarity of learning to find similarity between the text and the image.
You can also call it image captioning, right? Captioning a textual caption for an image.
Like you can actually repurpose it. So yeah, so in a way, like this can be used for that. So you can use this as a discriminator to kind of train an image captioning model. So people have used it for caption to image generation as well as image to caption generation. Like they've modified the clip for that particular purpose. Currently, we're using the base feature that is image to text similarity.
So even if we give a new text and new image,
any new text. So generally, any new text, any new image, it will work. So we do have a web demo there. You can try all of your different images from Google, download it from Google, put a few text, and it will automatically. So that's why it is called zero shot. Zero shot means you're not training your model for new classes. Generally, if you let's say you train a dogs and cats classifier, you cannot use it to classify between cars and buses. You'll have to retrain it, right? But with clip, because it's zero shot, you can actually, without retraining, you can just specify your classes, specify your image, and it will automatically classify it because it is so good at finding the similarity between the text and the image.
So even for non-Google images and text, it will classify, right?
Anything, any image and text.
Oh, that's great. Okay.
But it's not an OCR. There was a question. It's not optical character recognition.
Well, like in testing, it has actually been like even in the paper, they do mention that they have used clip for OCR, and it worked quite well. So it's not like
you
perfect,
you have to give labels. So you have for an image, you have to give potential labels, right?
You'll have to give the labels though. But if you couple it with a GPT-2 or some kind of text generator, you can kind of reverse. Then that will be training kind of separate thing. But yeah.
So if I have a use case,
given an image, can it output a caption without giving possible image labels?
No, by default, no. But there are modifications that have been done where you can do that. So you basically use clip like a judge, which and a generator, text generator. So let's say like BERT or some kind of GPT-2 text generator. It will generate the text, and clip will basically say whether this text and this image match or not. And accordingly, it will generate some other text. So it's like a beam search happening through the generator. to find out whichever one is the best fit for that particular image.
Adversarial, or you can put it in an adversarial mode.
So
Event
you can
generator
think of
also.
it like a GAN. So clip is like a discriminator, and then we have a generator.
Got
Use
it.
it like that. I think also someone was asking some question, I guess.
Yeah. So if we have a use case like, let's say from the invoice statements, right, we have to pick up the invoice amounts and the name and everything. Can this be used there?
I
Like
guess
from the
you can
receipts,
use, you'll
yeah.
have to actually test it actually. You can try it and see.
Okay.
I haven't personally tested it, so I'm not sure. But if you're, let's say if you have an invoice and if you have already cropped out the particular regions with some other model, let's say the amount, and if you want to, or you can just create a crop, multiple squares, create a grid of squares, and then run clip with amount, and whichever one is the amount, you can actually try it and see.
Okay.
It may be accurate, it may not be accurate. Depends.
Hello. I also have a question.
Hello.
Am I audible?
Yeah.
Yeah.
You're
Actually,
audible.
I'm working on a project that is related to sign language, that it will detect the sign language. So can I use it there, like the clip one? I will give multiple
You can
images
actually
of
try
sign
it.
languages.
Sign language, you mean the American Sign Language kind of ASL thing where you have different
Yes, yes,
signs
yes.
and that means different
Yeah,
words.
yeah.
I'm not sure though. It might work. Actually, I don't think it might, because every sign has a, unless that was in the data and then it knows that. It might not, but you can try it and see. There's no.
Okay, so I have to basically go through all the documentation with the clip, whether this is already present or not.
Or you can just simply test it even without going to it. Just take this
Okay.
thing, use that sign language image, and use your, let's say you have a word for trees and then cars and something, there are words.
Okay,
You just
okay,
put them here and see if it is making the right predictions.
okay,
That's it.
okay.
You don't have to do any other thing to
Okay.
test it.
So output
Yeah.
classes need to be mentioned. We cannot get away
Output
with not
classes. Yeah. So
mentioning
this
output
is
classes.
yeah. So the default clip is basically an image to text similarity. So you need the text and the image to find the similarity between them. Yeah. So
Krish,
yeah. So this is yeah.
yeah, question. So is it clip is the state of the art architecture for image
Yeah.
captioning?
Yeah, so for image captioning, so it depends on the person who is training. Like the default model is not for image captioning, right? But you, as I told you, you can use the clip model as a discriminator and then use it. And many people have done it. I don't think it's a state of the art, at least like in that modified version, because that depends on the developer who developed that using
So
clip.
it's not classically a image captioning solution. Image captioning actually means generating language after seeing an image. So here it's not generating language, it's just classifying from one of the available labels. So you have to have the potential classes which are shown here, right? If I don't have those classes, it has nothing to match it to. So it's a image to text matching algorithm. It's not a text generation algorithm.
Okay.
But we can use it in combination with a GAN, which is generating suggested text, and this can be act as a judge or say, oh, the suggested text is good or not good. Image captioning typically uses sequential model at the end, right? CNN to RNN transformation. So in image captioning, typically you have to have generative technology using RNN or NLG at the end of the feature detector from image. So a generator is needed for image captioning, which we don't have here.
Yeah, and in general, as for image to text similarity, clip is definitely the best model that you can get for finding the similarity. So, but but definitely many people have actually, I think there's also a music video where they used a style GAN and a clip model together to kind of turn the lyrics of the song into a music video, because clip was used to as a discriminator and style GAN kind of generated the images. But for text to image similarity, this is quite useful, or like I guess I would say like very good in general. So you can actually use it for zero-shot object detection as well if you want to. So you have a class, you can create a grid of boxes, and run a sliding window sort of thing to kind of do object detection without any training also. So that's also being done. I think in the paper they have mentioned a few other applications of it. Object detection, OCR, you can even do moderation also. So let's say you don't generally if you're a moderator on a group chat or anything, or a Discord server or anything, you usually have to manually go through stuff, but you can use Clip to kind of moderate images in that way. And you can use the previous workshops Zero-Shot Text Classifier as for text classification. That kind of makes it like a both image and text moderation. Yeah, but there are many applications just based on similarity for this. So.
For this exact purpose, it is state of the art. So for image
Yes.
to text similarity, it might be pretty much state of the art.
Yeah, it's the largest and the pre-trained model that's available right now there. So yeah, I would say it's pretty much state of the art in terms of image to text similarity.
So one question, suppose if you want to use this kind, if you want to develop a model for computer vision to detect objects, you can straight away use it and see if it works for your task, right? Without any
You'll have
training.
without any training, yeah.
If it works, maybe you can actually take it.
Yeah. Yes.
Okay.
Yeah, you can also in fact use Clip to kind of do labeling of your data set. So there's something called weak supervision, where you have, let's say, 100 good quality labels that you manually labeled, but you have 1,000 more images, but you can't manually label them. So what you can actually do is you can use Clip to label your images accordingly, and then train a object detector on that data set, which is automatically labeled by Clip to make it more accurate. So even if Clip is not accurate that much, you can use that kind of Clip to do weak supervision and make it more accurate.
Okay, so you're basically saying you can fine tune basically, right? With the images that you have at hand. Okay.
Yeah. So
and somewhere you have to specify the threshold here, right? Like, if it has to match
so we can actually specify a threshold, yes. But in this particular case, I didn't do it. I assume that all of the classes, like either one of the classes does belong to one of that image, but you can definitely specify a threshold if you want to. So the cosine similarities are usually in the range 0.3 or something like that I've observed. I haven't seen any instance where it's perfect one similarity for an image. But yeah, you do get 0.35, 32, or 34, or 39 and 4, up to 0.4, I guess. And based on that, you can set a threshold that this is the acceptable threshold, then do it. But right now, I didn't put any particular threshold as such. But you can, so this logits per image will contain those cosine similarities, right? So you can use that to get the threshold. And then if it matches that, then go ahead and apply the softmax and those sort of things.
Okay. And this, you said the retraining or the fine-tuning training.
That is not in this particular notebook, but online you can definitely find a lot of such examples.
Okay, fine.
Yeah. So this is how we are making predictions. So if you look in your left, if you look at the file manager, you should see a inference.py file. So just click on that. And you should see that all of this notebook code here that you just ran, what I did is just put it into a single class where you can open it, load the model, created a pre-process in that class, a forward function to kind of do the softmax and cosine similarity stuff, and a post process and a predict. So just so we can directly, so when we deploy it, we actually have a single class. Even without this directly, also if you have separate individual functions, then also you can do it. It's up to you how you want to do that. But just so that the final thing is all together in one place, I kind of just took all of this code. So I just took all of this pre-process function, the predict function, all of this code here, and then just split it and put it into different individual pieces like pre-process, forward, post-process. And then predict is basically a pipeline which will just do pre-process and then forward and then post-process. Also post-processing, nothing is but just like putting it into this particular list format. So I don't want you to get confused like what's post-processing. It's just putting it into this particular list format. So we get individual raw outputs, right? We want to put it like in this sort of way so that it's human readable. So that's what we are doing in this next cell. So from inference import clip image classifier. So this is the inference.py, and we are just basically importing this particular class from it. And clip image classifier, and we specify the model path, which is basically this .pt file. We had already created that variable above, I guess. So, and then when you run this cell, you get this output, the same output actually. So this is the development side of things. So that is the part where we build the model and make our model ready. So we even put it into an inference class. Even without that, if you had individual functions like this, even if you take the predict function and the pre-process function, the model loading function separately in a direct file, that also works. That's like during deployment. So it's just a matter of preference and style, like what kind of style you want to use in your code. There is no restrictions of any particular format. So, but of course, you can't directly just use the notebook for deployment. You do have to put it into a .py file. So that means it. So yeah, so that is the part where we built the model. Now comes the part where we actually deploy the model. So so this is the actual part that this workshop is about, deployment. So we developed the model, we built everything, we created our predict function, everything. Now we are ready to deploy it. So generally with CellStrat Hub API, this is how the deployment works. So like after you deploy it, when you call that, it is basically deployed as an API, right? So I hope everyone knows what an API is. It's basically like an endpoint or a URL where you make different kind of calls, HTTP requests. It can be either a post, specifically this is a REST API. So you can make a post request. Post means you send some data from your end and the server responds with something. So it's like you send something and you get a response. So that is called post in simple languages. And a get request is where you don't send some data, you just make a ping to it. So you just so it's like, let's say you're on let's say you're just trying to make a call to someone, but you don't want to talk to them. You're giving a missed call. So we sometimes, just to verify numbers, what we do is we just give a missed call, right? So get request is something like that. You just make the call, but you don't send any data as such. Only the server responds with something. So if it is ringing, we know that the number is right, or if the ringtone is ringing. So anyway, but yeah, so essentially we'll have your API endpoint is of this format. So HTTPS blah 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 api.cellstrathub.com/username. So your username. So if you notice, for anyone who signed up today, you would have seen that you had to set your username, and if you were an old user, you would have seen a pop-up asking you to set your username. So you set your username here, and you set your API name. API name is essentially the name of your project that you will decide. And then in the header, every API request that you make, there are something called headers. So headers are like metadata about your request. So you specify your API key in it. So API key is your authentication key, which should not be shared with anyone unless you intend to, but in general should not be shared with anyone, because every time you make a call with your API key, it will count under your 1,000 limit. So in general, you can see your quota limits here, right? So the number of API calls. So because I'm on the beta tier, I have 5,000, but generally you should have 1,000 calls as the free tier limit. And also when sending, a few rules is like when you send any inputs, there should always be JSON encoded. So in general, JSON encodable means anything like integer, float, dictionary, list, or string. So any combination of this is JSON encodable generally. So this is so your inputs will also be JSON encodable, and your output will also always be JSON encodable. So so these are just some general API stuff. And particularly in our model, how we are going to do is we are going to name our API clip classifier, and we are going to deploy it as like this. So we'll set the username here, our username, when we are making the call, and in our request body we'll send our image. Now in general, when sending an image, you usually send images in base64 format. So image is like you cannot, because when we are sending an API request, generally we can't directly send the file as it is. We usually encode it in some kind of format. So what we do is we turn our image into bytes. So we read our image as bytes and then convert it into base64. So base64 is the format of turning the of reading of converting bytes into a string sort of thing. So because I said, right, so JSON encodable means you can only send integers, floats, dictionaries, lists, and strings. So bytes is not there. So to send the bytes, we can convert it into a base64 string. We turn our image into that. And I guess if you're done any time web development or any HTML, basic HTML or anything, you would know that base64 is by default supported in all of those situations, and we'll actually do that as well. So, and then we'll also send the list of classes as our input because it is a zero-shot model, right? We define the classes and the image, and our response from our API would something be like invocation ID something something something. And this is the output from your model. So this is like the metadata, but this will be your final output from the model, which will be the plain 0.64%, dog 0.32, cat 0.04. The same output that we had in our notebook, right? We had a list of tuple sort of thing. So here also we have a list of different lists. Like generally in the API call, tuple gets converted to a list. So that's why. And in general, the deployment can be done in 3 steps. So the first step is you initialize your project. So during initialization, it basically generates a bunch of boilerplate code and templates. Then you integrate your own model. So there are, so I'll just go over that in the hands-on, you'll get that. And then we'll put then we basically build and deploy it. So there's not much that you need to do actually kind of to make it happen. So let's get started actually. So what I want you to do is let this notebook be open. Don't close this notebook. Let it be. Yeah. So what I want you to do is click on this plus icon and open up a terminal. So click on the plus and open up a terminal. And then what you need to do is you can just do hub init and then clip classifier. These commands are actually also in the notebook itself. So if you want to follow, so here the hub init clip classifier. So you can name it anything, not just clip classifier. For now, we'll just stick to a single thing just so we all are on the same page. So hub init clip classifier and run it. So what this will actually do is, if you see in go to your root, so if you just click on this folder icon, you will come to your root and you should see a clip classifier folder here. Is everyone seeing that? Just put a yes on the chat if you have run this command and you see this clip classifier folder here. I just got only 2 yes, 3 yeses. What about others?
So this creates a Docker folder where things will be set up for Docker deployment, right?
Yeah. But even if you don't know Docker, that there's nothing to worry because there's nothing to do with Docker in general. If you want to deploy it, the Docker is just the internal mechanism, but you do have flexibility to modify the Docker file if you wanted to, but generally it's not it's not required. So you don't need to know Docker or anything about what it is to know about that. So, okay, so I do see a lot of yeses. So yeah, so after you open up, so this is, has anyone ever done web development here? With maybe with React or Vue or something.
Bhavesh, earlier you were explaining get and post. You said telephone. It is like giving a missed call.
Yeah,
Can you please repeat that? What did you say?
Yeah. So post request is when you have an API. You're making a call to that API, but you make a call and you also send some information to go along with it. So so post is like it's like an email. Let's say you send an email and you get a reply from that email, right? From that other person. Get request is just like a missed call. So you send the request to the API, but you're not sending any information as such. In a missed call, you don't open the call and start talking, right? You just call it once and then just cut it. So you just make the call, but you don't send any information, but the other side does respond with some information to you. So in general, this in case of missed call example, this could be something like a ringtone ringing that, okay, this number is valid, or those sort of thing. So that's some kind of feedback. So when you make a get request, you're essentially getting some information from the server, regardless of whether you send off anything there or not. So you don't send anything as the input, you just directly get the output. So
you usually do that GET request just to check whether the server is fine, is it? What is the intention of the
So in general, in Hub API specifically, post request is used to make predictions. So you send an input, you get an output. Get request will actually be used to ping the model, so it is loaded. So because this is serverless, your model will always not be ready. It will get out of memory, it will be cold. So when you ping the model, you will actually wake up the model. Okay, model, get up, you need to get ready for inference. So so that when you make the inference, it immediately gets your response. So if you remember from the last session, we didn't have that feature, but now that feature is there.
So in
to kind of wake up the model.
Okay, with the GET request, you are basically loading the model into the memory if it is not there.
Yeah, loading model into memory with GET request. Yes, exactly.
Thanks. That's a very good analogy. It's called. Thanks.
So in your clip classifier folder, after you run the init, let me just walk you through all the automatically generated files. So you should see a Docker file, which you should not worry about. There's also a hub config file. So this is like the basic file which defines whether this is a Hub API project or not. It doesn't contain much. You don't have to do anything to it. It just contains the name of your project and the version. You don't have to change anything there as such. There will be two main folders that you need to be concerned about. One is the SRC folder or the source folder, where all your source code will reside. Also, there's a bunch of boilerplate here itself. And in model, this is an empty folder, but this is where your model file goes. So we had the .pt file, right? vit-b-32.pt. So we'll put that model file here. And in the source, you have a bunch of things. So the requirements.txt is for any libraries that you want, because for your deployment, you need to specify what libraries you're going to use, right? So the execution environment knows what to install and run. So it is also an empty file, but you will specify a list here. We'll get to that point in a second. And in main.py, this is the main file which will get executed. So here, there's a inference handler function where you'll have your inputs. So this is where you get your inputs, right? So your inputs will be your raw JSON input. So when you send an API request, your inputs will be a raw JSON input, and you do something with your model. So to make the prediction, you get some output and you return that output, and that you will get in the request. So it's pretty simple. No strange formats or anything. You get your input, do something with it, and return the output. That's it. And your model is not stored along with your code because it's in a different folder, right? When you are implementing it, you get the location of that folder in this environment variable called model dir. So generally in Linux, in Windows, any operating system, there are something called environment variables, where they are like temporary variables you set throughout the system, where you can set particular values to it. So in this particular case, we have a model dir environment variable, which will give you the value of your location of the folder in memory, but you don't need to know the exact value. You just need to use that. So that's why this boilerplate already is there. And then some other things if you want to do import or anything. And then there's also utils.py. So this is basically a utilities. It depends on your use case. By default, we provide a convert base64 to image. So we'll actually use this function because, as I said, we'll be sending our image as base64 string, right? But our model is not going to accept base64. It's going to accept a pillow image and then convert it into a vector, right? So for that, we'll actually use basic convert base. So you can use this function to convert the base64 to either NumPy format or pillow format. Pillow is basically the PIL thing, right? So the Python image library. So these are just some utilities. You don't have to do anything here. So this is the general boilerplate that gets generated with your deployments. You get it's like a cookie cutter. You get all of this thing ready for you to deploy. So now what we are actually going to do is, for one thing, I wanted to go to source and delete all these 3 files because I already have those 3 files. You can just directly paste them and I'll explain them. So just click on delete and delete all these 3 files in the source. Then go to your Zero-Shot Image Classification folder, and in model source, you should see a folder called Clip Hub API under our original Git repository that I showed you. You should see a Clip Hub API. So under that, go open that up and you will see a similar thing here, but you just need the source code. So just copy all of those 4 files. So you just copy all of these 4 files with copy or cut, it's up to you. I'll just copy it for now. And go to your clip classifier and then paste it here. Generally, you can directly run it from there as well, but I just wanted to show the full process, the life cycle process. So from init to the end. So,
can you please repeat this? We
yeah,
had to go to clip
I'll just
classifier.
repeat it. So in your clip classifier source folder, there were already 3 files, right? So what you do is you just delete those 3 files in your clip classifier source folder.
Okay.
So is classifier source folder, delete the 3 files. Now the second step is go to the Zero-Shot Image Classification folder. So Zero-Shot Image Classifier, go to model source, the place where we had our notebook, right? In that same place, we had a folder called Clip Hub API. Go there, go to source again. So this is a kind of like the same project. You can actually run the project from deploy API from here itself, but we'll not do that right now. And basically, I'll just copy path. So copy all the 4 files from here and then go back to this particular
Zero-Shot deployment model source.
Yeah, so you'll find inference.py, main.py, requirements.txt, utils.py. Essentially, this is a replacement. So we are essentially replacing the files, the final source code from here to there. You just copy it, go back to clip classifier and paste it here. So just pin this thing here.
So basically,
So-
Hub init created a folder, which is the final package of deployment.
Yes.
That's what Hub init did. But that package needs to now get the relevant files from that original classifier we were working with.
Yeah. You can you will also do another thing apart from those 4 files that you just did. You go back to this model source and copy this vitb32.pt file, right? So just copy it or cut it. I'm going to cut it. And go back to clip classifier and paste it inside the model folder. So this model folder will decide any of the large files. So because this is a, I think 337 MB file, right? So any large files, model files, those sort of things will all go into the model folder. Usually. So finally, yeah, I'll just put another step. Copy the vitb32.pt file to the text classifier model folder. So
where to copy that from?
From the original place where we had our notebook, right? So we had it in our Zero-Shot Image Classifier deployment model source, and then we had a file here we had downloaded to run alongside the notebook. I just cut it and pasted there, so it's not here. But yeah, you are probably seeing that if you ran this notebook.
Sorry, it is in this model source, is it?
Yeah, inside model source, you should see the .pt file, vitb32.pt file.
Okay.
And then copy it into the clip classifier model folder. So first we copied the clip classifier source files. Now we copied the clip classifier model folder file. And until then, I'll just explain the integration steps. So if you notice in last slide, I had a integration step here. So integrate your model. So what we did is we put the model files in our model folder and we put our source code in the source folder. And we updated our main.py and requirements.txt. So I'll just show you what I actually did there. So the reason I told you to replace is because you might have deleted only these 3 files, and again these 3 files are here, but these 3 files are a bit modified. So this is the inference.py from our original notebook, right? So we had tested this inference.py here, right? Inference clip image classifier. So this is that same file. So I'll just put this here so you know we're not lagging. So we had this thing. So this is as it is put here. And then in my main.py file, what I actually did is I imported that clip image classifier. So the same thing like this. So I from inference import clip image classifier. Here also I did import inference image classifier. And also from the utilities, from the utils.py, imported this convert base64 to image. So yeah, so I imported that as well. Now this was already there. I added this extra line. So this line was extra. I'll just mention whichever lines I added this part. And all of this part is all added again. This part. So these 4 lines are also added. Essentially 2 lines, the print, if we ignore the print statements. So I initialize the model similar to that. So we initialize our classifier like this, right? So clip image classifier, and we specify the model path. So if I told you, right, our model files will reside in this model dir. So what I did is because our file ML is, I just basically joined the model dir and this thing together. os.path.join. This is used to join different paths and file names or those sort of things. So initialize that, and in our classifier, what we did is first we want to convert our base64 image, right? So our from our this thing here, if you remember, we decided that our model specs will be like, again, this model spec is not fixed. This is my own choice. I made a choice that I will send a dictionary like this to the API, which will have the image key and a classes key. This is all completely up to you how you want to define it, as long as it's JSON format. So I decided that I will have I'll send a dictionary with the image as one key in base64. So I use this utility to convert it into pill. And then I also have my classes already here. So then I use my classifier.predict and put in the image and the input classes here. And that's fine. That's my final output. And then I just return that output. And in my requirements.txt, again, I put 2 things. So one is torch, and this library was actually installed from Git. So that's why Git plus thing, this thing. So if you remember at the top first cell, we had this pip install Git plus github.com/openai/git clip, right? So I just added that Git plus thing. This is basically the name of the library essentially. So because it's directly installed from Git. So there are only 2 requirements for this, torch and Git. NumPy, Pillow, those standard libraries are already there, will already be provided in the deployment, so you don't have to specify them separately. So these are the general things. So these are the 3 different, so these are the only changes. So utils, there's no change actually. So the only change where you made is we added our source file, we added our own prediction code here. I guess only 1, 2, 3, 4, 5. Yeah, so only 5 lines of code we added in our main.py, and then we added our deploy requirements here, and that's it. That's your deployment. You don't need to change. You don't need to do anything as such. Like, of course, the build and deploy command, but apart from that, you don't need to do anything for integration. So does anyone have any questions on what this is doing or how this is working or anything? If you have, also, I hope this process was clear, the copying part. If someone was lagging behind, just let me know and I can repeat it again.
Bhavesh, I have a question on your layout, whatever you have defined the JSON format. You have predefined those classes, right? Dog, plane, cat. What if it is any other class?
No, this is not predefined as such. I was just giving an example here. You can put it any number of whatever classes or any number of classes.
Okay. So I thought we have hard coded these 3 classes.
Zero-Shot, right? No, because it's Zero-Shot, right? So we can send any classes that we want. So this is basically my input to the model. My input gets this, my model gets this input. I then do some kind of pre-processing stage kind of in a way. So I just convert this image to normal format. So that's why I'm using this function called convert base64 to image.
Okay.
So this is available in utils. So from utils import.
Right.
Yes. And then I just use my predict function here. So classifier.predict image and my input classes. So classes, I don't have to do anything. So I just directly use this. this format, I defined it based on my requirements. So there's no specific format that you have to follow for every other model. This is my way. So generally, I guess there's not the other way that you can do it. I guess this is the only way. But the other way would probably be like having a list of lists. So where you have a first element as the image and the next element as the classes. But yeah, in general, this is your own way of doing things. So this is in this particular case, we defined it such that it's such that you define your image and you delete your classes. So this will be the input to our model, the API model.
No,
So when you make
typically,
a post request.
so what I was saying is, you don't know what the image contains, right? That is what you want to predict.
Yes,
Correct.
yes. So that's why in our input, we also send the image as well as the classes together so that we can always switch it to different classes if you want without having to hard code anything in the model.
No, if the classes are not known, it can be any class, right? So is a class
No,
is a
we'll
must.
actually have to define the classes. We'll actually either be it plain dog, cat, or whatever. We'll have to define a set of classes because this is an image to text similarity, right? So it will compare this image to each of these classes and tell us which is the highest, which is the most similar one. So in this case, it is like a plain image, let's say.
So it actually takes plain also as one of the inputs. It takes the
Yeah,
image as
plain
well as
dog, cat, all of this is our input. So the image and the classes, both is our input.
Okay.
So Krishna, this is not out of the blue, image classification. This
Okay.
is, labeling image from a given set of textual classes.
Oh, okay. So it's a given text. So it actually, okay. I was thinking it's out of the blue only in the sense, no, any image it can, the nearest classification it can do. It's not that.
That's a
You give your
generalized
text.
object detector. This is not the generalized object detector.
Okay. Look, but clip is that, right?
No,
It's
clip
a-
is
Yeah,
also
clip.
having labels only, right? You noticed.
Yeah, but you in your clip only do specify the text as the input. So text is also an input, image is also an input. Both are as an input, but we can send multiple text and a single image and check which text is the most similar to this particular image.
So if the image
So
doesn't match the given set of
then
classes,
also it will give something. It will give something, but you can set a threshold as you mentioned
okay.
earlier, right? You can set a threshold if you want to restrict that.
Okay.
In this particular case, I didn't do that, but we can do that. It's not a, you just have to add one line of code, like a greater than, less than, equal sign.
Right. Yeah, got it.
No, what it might do, let's say you give 3 classes, it might give 40, 30% probability. So because all of them were kind of bad, so it may just give you 40% probability for first label, 30% for second, 30% for third. So it is not able to, because all 3 are kind of bad. You didn't give a good one. So that's what it is, yes.
So the softmax makes sure that it is 1 for the given classes.
Yeah, we're just normalizing it as so that the sum of all the probabilities is 1.
Okay. So I was thinking actually the other way around. It can actually
No.
without,
Like you can do it, but like you have to modify it in that sense. There are ways to do that, but that's a different topic.
No, generalized object detectors are trained on, ImageNet and all like ResNet or VGG. Right?
Yeah, but
or
even those
FHML.
have a limit of only 1,000 classes, right?
Right.
That is the data set. But here you don't have a defined set of classes. You can define whatever custom classes that you want.
okay.
These are all custom classes, right? So
Okay. Suppose if I have some 10 images which I want to classify, I can always fine tune on this clip, and I can say I can actually pass those classes.
In general, for image classification, clip works pretty well. So generally, I don't think so. ImageNet has kids playing as a class, right? Definitely it doesn't. It probably doesn't have Elon Musk wearing a face mask, those sort of things. But yet, clip was able to do because it knows the contextual meaning of the sentence and the contents of the image. That's why it's able to make that prediction. Yeah. So just can you put a yes in the chat if you're all ready, if you have copied copied the source files and the model file, and if you're ready to kind of deploy it.
We don't have to change anything in that main.py, right? It's already there.
Yeah, so you copied the files. If you copied the files, it should look something like this. So if it is already looking the clip image classifier, this part is already there, then you don't need to, because we copied it directly, right?
Yes, right,
yeah. This time I just put the source code directly in the GitHub so that you can directly copy and paste it instead of writing it, right?
Yeah.
But yeah, generally, if you were doing it for your own model, you would have to write this particular part. of making the prediction. You just now, because there's a workshop, we already have the source code for that particular part.
So this can be used for image search, right? I upload an image, want to find the name of.
Yes, this can be used for image search. So let's say you have a single text but a bunch of images. You can, let's say you are searching for a dog, for all your dog images in your gallery. You can just search for dog and it will all match the text dog with all of the images and give you the ranked list of all those images.
No, I missed that part. So it doesn't do image to image matching, right?
You don't need to do image to image matching. You can directly search your search queries. Let's say dog is your search query. It will find all the images in that dog. In Google Photos,
there is a use case. Let's say I like a dress, right? And I'm looking for that
for that
dress
it won't be useful. Yeah, for that it won't be that much useful. For that, there are different methods, like Dino is a way where you can do k-means, k-nearest neighbor on using Dino vectors to do that. But this is more like a Google Photos kind of feature. So in Google Photos, you can actually search your photos using text and it will give you out the text. So let's say you had a family dinner at some restaurant. You can search dinner at this restaurant and it will find out all the images which match that search query. So this is Google Photos already has that kind of feature, which is what Clip is doing. So yeah, so okay, so I think I did get a lot of uses, right? So now go to that same terminal. So we had initially done Hub Init classifier, right? So just cd into that clip classifier. So just run this command, cd clip classifier, which is change directory, and that will basically do. And now you can actually run two commands. The first command is hub build. So I also mentioned it here, I guess, yeah. So after your integration, you can run hub build and hub deploy. So the hub, so you to run these two commands, you have to be inside the project. So that's why we changed the directory into it. So we went inside that folder and then you can run hub build.
Sorry, where we have to go?
In the terminal only, just change directly to clip classifier in the folder, this folder where this clip classifier folder, and then go to and run hub build from that folder. So the hub build can take about 2 minutes or something because it's kind of building your own entire Docker image and everything, and installing all the libraries.
SRC?
Not under SRC, just in the clip classifier folder, not into any, just the clip classifier, the folder where there is a Docker file and the hub config.json.
But Bhavesh, actually, what is the GPU it is taking now to load this clip model?
Nothing. We are running everything on the CPU, and it still works quite fast. It's like within 1 second, I guess. I think I do have. So yeah, it's you don't need to use GPU to run clip model. It works fine with CPU.
See, and in this dashboard also in that hub, we have not specified GPU to be used, right here.
Yeah. Also, we in the free tier there is no GPU available as of now, at least for now. In the future, there will be a free GPU provision in the future, but for now there is only CPU available.
Okay. And because there is no training, we are not getting into any issues here.
Not training.
Okay.
Yeah. In general, the GPU is available, but it's kind of paid as of now.
Okay.
The gamma tier we have.
Yeah, the gamma tier.
What about beta? Does it have GPU?
No, alpha, beta are just extensions of the number of current usage and your storage. The tiers starting with G are the ones with GPU. So gamma plus, those any of those. I think. Yeah, we have a gamma tier and a gamma plus. So gamma tier gives a T4 GPU and gamma plus gives a V100 GPU. So V100 is like one of the most powerful GPUs, but T4 is like the usual GPU that you'll find in general, but it has like 16 GB of memory.
So internally, which is it also using one of the clouds here? This
yeah. So it's based on AWS. So
AWS. Okay.
You can see in the URL. It's an EC2 cloud on AWS.
Okay. Right. Yeah.
So after the hub build command, so hub build actually, if you know Docker, then it's actually building the Docker image. But if you don't know Docker, then what it's actually doing is, to be put simply, is it's building a package. So it's installing all the libraries that you specified in requirements.txt, right? So we have two libraries, torch and clip library, and it's copying the source code into a Docker file, so into a Docker image. So in general, it's like a package. So it's building that package. So it's building the, so let's say you want to send some things to your friend across the country, and you'll use courier service, right? So to send, before that courier service, you package all of your items into a single box, and then wrap it around with tape and everything, put the label, everything, right? So hub build is actually doing that. So it is putting all of the source code, the libraries, everything into a single package, and then putting a tape all around it, and then sending it, and then just preparing that and just keeping it ready for deployment. So it's like a ready deployment to deployed. So this Docker image can actually be deployed anywhere. It's kind of like, that's the point of it. So the hub build is essentially building that package. I hope that's clear. Pratiksha.
Yeah. So what you are building here is a Docker container, right?
Sorry,
What
your
you actually
voice is
give it to others is
breaking.
Docker
Yeah,
image.
it's a Docker image.
Copy of this. Is right? So what you are preparing here is a Docker container, and what you send it to others for any deployment is a copy of this. That is a Docker image.
That is the general use case of Docker image. In this particular case, we are automatically deploying it on AWS. The Docker image, also you don't need to know Docker to deploy it, because we have our utility. So hub init, hub build, it is already taking care of all of that without you having to interfere. So everything is ready-made for you to deploy it straight away. So after the build command, just run the hub deploy. I'll send it in the chat as well, and it's also in the notebook instructions. I think hub deploy. So now we have our package ready. Now what we are doing is we are pushing it to the cloud and making the API available. So this is the part where we are deploying the API. So we have our package ready, we have our source code, everything, libraries, everything ready. Now we are deploying it to the cloud as an API that can be called from anywhere. So as you can see, you can actually see the size of your built final package. So this is 2.892 GB. Most of it is, I guess, is used based because of Torch, PyTorch, and TensorFlow. Those deep learning libraries are quite big in size. So generally, those take, and that is the main size, because your source code is very small, right? These are like a few KB, I guess. This is 732 bytes. This is 44 bytes. This is 851 bytes. This is 2.4 KB. So these are all just small pieces of code, but the main size comes from the libraries. So again, this can take a few 1 or 2 minutes, I guess, to completely push it. So in essence, and if you know Docker, then what this is actually doing is we are pushing the Docker image to a Docker registry. So to our private Docker registry. And then after that, we'll actually deploy it as an API as well. So both those steps happen simultaneously in the hub deploy. Yeah, and where can we see the Docker image? You can actually, if you have used, you can just open up a new terminal if you want, and you can see your list of Docker images by using the usual Docker commands. So, and yeah, and the hub deploy, as I told you, hub deploy is essentially taking that Docker image and pushing it to the cloud registry. So there's a Docker hub, right? You might have heard of Docker hub if you know Docker. Similarly, there's also the Docker hub is a public thing. So similarly, we have our own private Docker registry in AWS. So that's called Elastic Container Registry. So we are pushing that Docker image there. And after that, we are deploying the Docker image as a serverless API on Lambda. So as an API, and it's basically creating that API resources so that you can call that API as a URL. So you see this, there's a URL, right? For each of your APIs, there will be a unique URL for that. So based on your username and the name of your API. So you can see push. So it has pushed the image to the cloud repository. Now it is deploying your model as an API, and then update. I've actually previously deployed it, so that's why it's saying updating existing deployment. But in your case, it should say deploying your model itself. And then after that, you should see model deployment complete. So that's it. So deployment side of thing, it's pretty straightforward. You just have your predict function, import that predict function in main.py, do any necessary prepare. If it's a base64 image, you can use the utility to convert it into normal thing, and then just make the prediction and return the output, and then run hub build and deploy. So which are just 2 commands consecutively. And after that is deployed, what you can do is you can start running this cell. But before you run this cell, there is actually 2 things that you need to change: the API key and your username. So firstly, let me just ask, has everyone's deployment complete? Is everyone's deployment completed? Like you see the model deployment.
You're still deploying for me. 1.9 GB out of 2.8 GB done.
Okay.
Pushing.
So if it's completed, if the deployment, if both hub deploy, hub build and hub deploy, both those commands have run, just put a yes in the chat if you've done. Meanwhile, I'll just explain a few other things. So now generally, as I mentioned, to make your API, you have your own unique URL, right? So it starts with api.cellstrathub.com, and then you put your username. So if you have when you signed up, you might have set a username, right? Even if you don't remember it, you can just go to my profile and see your username. So this is my username. So just take that username and put it here in your username, while even if it's while deploying, still deploying. And in your API key, you have to go to deploy models, and you should all see a default API key already there for you. You can click here to reveal your API key and copy it to clipboard. And you can see API key copied, and then this, and then just paste that API key here. So this is your private API key, and you don't need to technically share it with anyone else unless it's, yeah.
But Bhavesh, where to change the username? Which file you said?
Your username was probably in the my profile. If you go to the dashboard on top of
I
your
got
name,
it. No,
uh,
yeah, no,
in the
yeah.
notebook,
Which file we have to
in
change
the
it?
notebook, if you scroll, in clip.ipinb, in the clip
Which
notebook,
clip.api.
it's probably already open, right? So just scroll down and you should see the test the deployed API session. So
should I create the API key?
So that is the clip classifier.
is it not already there? If it's not, or it should, you don't see a default one there.
Yeah, I don't see.
Okay, if it's not there, you can click on create API key, and then if it's already deployed, then you can select all your both models and click on create API key. I think it should be there. I'll recheck it again. But generally, it should have been there. Maybe I made a mistake somewhere. But yeah, but you can create an API key if it's not already there. So if it is already there, you can use click here to reveal API key and click on this copy icon to copy to clipboard. If it's not, just create API key, and in your model access control list, you should see clip classifier. Just select that and click create key. So meanwhile, if you are already talking about creating API key, you can actually have a single. You can actually have, like, if you have multiple models deployed, you can actually use different API keys for different models if you want to. So that, let's say by mistake your API key got leaked onto the internet and someone is misusing that, it will not do that much damage because it will only be able to access one of your APIs and not all of them in general. So, but if you select all of those, then you'll get, probably if you're deploying it for the first time, you'll see all models deployed because that's the only model that's there. So all models are. And you can also delete your API keys and edit the access. You can enable or disable API key if you want to temporarily, or those sort of things. I'll just delete mine. You can create up to 10 API keys in general. Yeah.
But sorry, I missed the point again. Which file that user or my profile has to be, username has to be?
In your Zero-Shot
to
Image Classifier, mode
clip
deployment.
classifier.
Zero-Shot Image Classifier. No, not clip classifier.
Oh,
Model source, and then the clip.ipinb notebook. The first notebook that we had run from in the beginning, right? So that notebook, clip.ipinb.
okay. In the model source.
And if you scroll,
where is it? Zero-Shot
in the
Image
model source.
Classifier deployment. Okay.
Zero-Shot Image Classifier deployment, model source, and then clip.ipinb. And then if you are again running it, just make sure you run one of these, at least this cell. And then you can scroll down to the test. You can scroll down to the test deployed API cell, this section, and you can replace your username and your API key here. And then just run that cell. And also, if you want to just look at the endpoint, you can just print endpoint, and you will see that API.set@home/ your particular username and your API key, your API name. So this is basically a project name, API name, whatever you want to call it. So yeah, so just put a yes in the chat. API key from your deploy dashboard.
Sorry,
from
what
your
is the
API
API
dashboard,
name
you
you
can get
said?
your API key. Clip classifier. You don't have to change it or anything. It's already written there. So if you follow the exact same step as mine, it will still be clip classifier unless you changed it, named it something else.
No, it just says app API name, right, in the brackets.
You don't have to change anything here. You
Okay,
just put your variable. So yeah, that's the variable name, right? So that's will automatically replace it. You just put it in the
Oh,
API
there's a
key is
variable.
equal to this part. Username is equal to this part.
Okay.
So we are using a f string here, right? So format string where you can replace values with the variables here. Yeah, so just put your username, this thing, and you can actually run all of these cells if you want to while you're waiting. So the first thing we actually did is, before making our prediction, is we made a get request. So we did request a get the URL. So our endpoint is our URL, right? And we put our headers. So headers is basically two headers we have here. So X API key, where we specified our API key, and the content type. So this is optional even without do, but it's better if you always specify content type as application/JSON. And if you make the request, you get it will basically load your model in memory, so you can see the responses model loaded in memory. So after that, if you make the predictions, yeah, I guess we already got the predictions here. So we got our predictions. So I sent. So let me just explain what we are actually doing is also when we are sending our image, if you remember, I told that we are sending images as base64 strings, right? So in Python, if you want to convert an image to base64, what you can do is you can just directly open up that image. So what I'm actually doing is I'm just using loops to kind of open up all the images, all these five images. Yeah. So open up that image, and we are doing is read as bytes. So RB means read bytes. So when we do f.read, we get our image bytes, and then we can use base64.b64 encode to convert it into bytes. So this will again be in bytes format, but still in base64 format. To convert it into a string, we can do .decode UTF-8. That will give us the image string, and we are just appending that. So this is just for in Python or something. If you're testing it, you'll do something like this. If it's an image, only if it's an image, you need to do this part, because you need to read because you're sending our model is expecting the inputs to be in base64 format. So and so it's basically multi-5 images, right? So I'm just selecting any random one image. I think that would have been the kids playing image, I guess, and then sending the classes. So this is my payload, and in data I'm just doing json.dump_s. So in general, if you have made any API calls in Python, you would know that you always json.dump_s your payload. So json.dump_s is basically converted into a JSON string, so from the dictionary. So while sending over the internet, you usually convert it into a string and then send it in the dictionary. And then we get so we are basically making a post request. So and .json is just to, when we get our response, we just turn it into JSON immediately. And then if status code is 200 means successful, and then we can do response body input output. So all your inputs and outputs are always in the body part. So even if you don't, so data is essentially what it's doing is even that is putting our inputs in the body of the request. So if you're using JavaScript, you would actually explicitly mention that as body. And you can, if you have already done web development, so you can actually look at the clip app source code. So clip app. So there's actually an app. I'll just go over that in a second. But yeah, you basically get the output also in the body. So we just do response body and then output. Response is a dictionary, right? So I'll just show you what the response is. We have our status code, we have our headers as the response. We have our body. So body contains our main So body again also contains the invocation ID and all of that as well. That's just for your reference. That is because if you go to clip classifier in your Hub API dashboard, from where you copied your API key, you will see all your invocation history here. So this is for your own internal view if you want to just check what was the input, what was the predicted output, and what time it was called, those sort of things. So that invocation ID is just for a reference to kind of do this in this particular section. And we have our output. So this is the output that your model gave. So the output that the model gave is basically present here. So
because you
output
pass the
kids
kids playing image string
yeah, it's
array
the
next to.
second image, right? So I think it's the
If you go up, you will see that input being here only. The image
string 2.
So I tried with
So
0 and
third.
1, so I get the Elon Musk and the plane.
So this is
so
the
on.
second index, right? So 0, 1, 2. So 2 is kids playing, 3 would be plane, and 4 would be traffic. So if I try with 4,
Bhavesh, I'm getting an
it
error.
should
It says
get
classes not
traffic.
defined.
So you run it again, right? So just scroll up to a part where there is this classes cell, right? So you might have closed it earlier. So just run this cell which says classes and then run it again.
Okay.
So because this is assumed you run it all in order, so that's why. But apart from that, you should be able to run it. So this is how our API is. Now, in general, I hope you all know that API is a generic generic thing that you can call. It's not language dependent. You can call it from Java, you can call it from JavaScript, you can call it from Python, Swift, Flutter, whatever language or framework you're using, you can call it. So we are currently doing in Python. That's why we tested in Python. Now we'll actually have a web demo as well. So because actually at the point of an API so that you can integrate it in your applications, right, and not just for server-side use. So after deployment, we'll actually integrate our API in this web demo. So I'll just share the link to the web demo. If you know web development, then you can find the source code of this web app here in Clip App. So it's a Next.js app based on React and Tailwind. Like if you know everything, then Next.js is a meta framework of React, right? So, and then we have Tailwind CSS, and then it's deployed on Netlify if you want to deploy it yourself, but otherwise it's already deployed and you can access it here. So it's classifier.netlify.app. I'll share the link here. So just open up that web app and you should, and then put your username / API name here. So I'll put mine here. And then copy your API key. So copy your API key and paste it here. And load model and run a load model first. So just so we we actually loaded the model already here when we're testing it here, so it's probably already loaded, but still we'll load it anyway. So this is like fixed to 20 seconds. So even if it's not loaded or not loaded, it will still take 20 seconds just to ensure that it's ready. So while it is loading, you can select any upload image. So you can, let's say I'm using traffic, I open it up, I specify traffic, dog, cat, mouse, or something, random classes. So just separate all your classes with a comma. And then if you click on classify image, you can see the model is generating the title. Oh, sorry, I might have, so in my other project, I had the similar UI, so that's why. Yeah, so as you can see, photo of traffic 100% and then dog, cat 0%. If you want to try anything out random from Google, so let's try with something different. So I guess okay, I'll just try something from some random image from a game. So generally you would usually use on real images, right? So let's try from some animated images and see if it's able to predict it. So I'll just save this image as this, and I don't know if it might work, it might not, I don't know. Try that. I'll just have Minecraft as one class. I'll have garden as another, because in this image there's also a garden kind of or a forest kind of situation, right? So let's see what it predicts. Yeah, so you can see photo of Minecraft 99%. Yeah, so it's very well. So similarly, you can try with any set of images and any set of classes and it will work. So this is because this is a zero-shot image classifier. That's the, you don't need to change anything. Like you don't need to retrain anything or anything like that. So similarly, by the way, just put a yes in the chat if you're tried with, yeah, all the classes are separated by a comma. Yes. So if you have tested the web demo as well, just put a yes in the chat.
Yeah, I tried with a random Elon Musk image and I added Elon Musk as a class and it worked fine.
Yeah.
But how are you? Okay, so Minecraft also. So as long as that, let's say the label is not there. If I skip Elon Musk, but I loaded an Elon Musk image, let me see what it will do.
Yeah, I also removed Minecraft from the classes. So
yeah, so it's giving
it
random
detected forest.
probabilities. It's giving random probabilities, but not very high for either of them. But if I put Elon Musk for Elon Musk, then I get more. Let me just try Elon, not even Elon Musk.
Actually, for me, it says something went wrong. Please try again.
Maybe just refresh your browser. Refresh the page.
Browser.
Did you put the API key, username, and endpoint, all of these here?
Hey,
the
Bhavesh, I tried
username.
something very strange. Yes, sorry.
The username, API name, and your API. So this is a web demo that is calling your API. So it's that you deployed right now. So
It is clip
so you have to
classifier,
put your
right? Name.
yeah, clip
Username and clip
classifier.
classifier.
Username / clip classifier.
Clip classifier, got it.
You can see, like, if you were not, you should see the example here, right? In the placeholder username / API name.
Yeah, right.
So, even from a Minecraft image, it is actually technically a forest in Minecraft, so it did predict a forest. But yeah, so in general, you can try it with any of your images. You can even try, you can even create a Google Photos like thing if you want to with this. So you can have like a gallery. You can have your own gallery, and you can use clip to kind of, let's say you want to search the image when you went paragliding or something, let's say, or let's say you went to Manali or something, and you want to find that particular image when you were paragliding there or something. So you can draw paragliding in Manali, and it should probably give. Let's actually try that.
Hey, Bhavesh, I am noticing something very interesting. I loaded Elon Musk image, and instead of giving Elon or Musk, I gave SpaceX and Tesla as possible words, and it's doing 99% probability
It
match.
will do. It's because it's probably like in the data set, it would have been like the image of Elon Musk along with his Tesla car or something, and the caption might
In
have
the
been
image,
Tesla.
it is just Elon Musk. No, not at all.
In the I'm talking about in the data set. In the data set, on which it was trained, it would Elon Musk is usually associated with all these companies, right?
So it's basically doing a word vectors like BERT.
Yeah.
So Musk is also associated with Tesla, and he's also associated with SpaceX, right? Like that. So very interesting. Okay.
Very interesting, actually. It is.
So it is like BERT, in that sense, because with BERT also I'm able to do that, right? So
the text encoder is a transformer only. It's BERT based only. The text part and the image part is a vision transformer.
So OpenAI is not working. I tried OpenAI for Elon Musk. It's not working.
Yeah, like Elon Musk funded OpenAI in the beginning, but he's not in OpenAI anymore.
Yes.
He left the company a while back.
Now I'm trying the word richest person. Yes, 99% probability richest person. Yes. I tried Elon Musk image with richest person keyword. It's matching. So yeah, there is something about it. Yes, like paragliding with Manali. Okay, makes sense. So there is semantic understanding also happening, not just exact word. Okay.
So I actually had a few images. Let's say I have actually tested. I don't know if it still works or not. Where is clip? So I have two images, one of cows in Minecraft. So again, not a real image, cows and cows at night. So if I have cows and cows at night. Let's see if this is able to get the semantic meaning that it's not just cows. Okay, so in this particular situation, it didn't. So, but I guess if I add another, if I use only cows, yeah, photo of cows only. Okay, at night it's nothing, but probably for real images it might be able to do.
So I tried
Nice.
Elon Musk image with $1 billion and rich people is giving $1 billion as 90% probability. Rich people, it did not match.
Yeah, usually in articles and all on the internet, it's usually a billionaire mentioned, right?
Correct.
You don't just say rich, but you specify what millionaire or billionaire. So
Mhm.
yeah, so in the data, because it's all scraped from the internet, so whatever you find out on the internet is how it might perform.
I think if we don't give the right class, right, it'll take the next image. So,
Yeah,
for
yeah.
example, I gave Tim Cook. If I don't mention Tim, if I mention garden, if there is any garden, it takes that.
Like it's basically taking the whole meaning, right? So we are sending a photo of cows, a photo of Cook, a photo of Tim Cook, or whatever, or garden, or photo of forest, or those sort of things. So all of things. So because we are appending a photo of also, even without appending, we can actually do it. You can actually modify it in the source code if you want to try that. Like in the classes, yeah, in the classes, in fact, actually, I guess in this particular case, I'm not appending that in this particular, in the code Python test thing. But in here, if you want to modify that, you can just go to clip app. Maybe I guess just go to pages, index.js. And there is a line on that. There is the predict function.
So Bhavesh, if we deploy it in our public marketplace, this is definitely worthy of that.
Yes,
Can we get a lawsuit from OpenAI for
no, it's
commercial
open source.
usage of this?
No, it's open source.
I mean, sometimes open source has a qualifier statement that you cannot use it for commercial reasons.
But I think this can be used
because we should put this in a public API marketplace, right? That this qualifies very well. It is extremely
this is an
generalized.
MIT license. This is an MIT license. That means you can use it for almost everything.
I see.
But there won't be any liability of OpenAI or warranty of any kind. Any of those things won't be there.
So we should put this in our upcoming marketplace, right? End of December, we are launching an API marketplace.
Yeah.
You can even have the client there, right? As a client stub. You can also market the client stub, right?
Yeah. And I can just modify this a bit and we can add this as the extra link for the client part.
So I have put some necklace jewelry and gave the class as gold. Identify. It's giving gold for 99%.
Yeah.
Nice.
You can actually try it in this. Maybe try with gold earrings and gold necklace, and then try if it tells whether it's earrings or necklace or chain or bracelet, whatever. Let's see if that works. And also add gold in the label so that it knows whether, then we'll be able to know whether it's rated as that or gold. Yeah, so in general, so Clip is a pretty fairly general model, and deploying it was also pretty straightforward. I hope everyone, I hope only the deployment part. So the development part set aside, the deployment part, I hope it was easy. If you found it difficult or anything, just let me know, and we'll try to simplify it further.
So Monima and Krishna, Kirtana, what do you all think? Do you think it's this kind of deployment scheme is easy for developers to use for deployment of AI as an API, or it is quite complicated for a developer?
No, I think it is good, but I feel that there are few things you can do, at least for demo and stuff, right? That deleting from files, copying that, right? If you can make some scripting and there's a parameter, you can give the whatever source folder and things, and so it will copy that, so we can save time and all these things, right? Okay, so.
So Monima, you are saying there are ways to simplify this whole process, huh?
Yes, that's what I meant.
Okay.
Okay, yeah, so surely the copy part, I guess we can do that, but I guess still you need to do the main part, because right now in this case, in the workshop files, I did have already coded it, right? So, but this part you would have to anyway do
Krishna,
that.
how do
But
you
the
feel
inference
about
doesn't matter.
the complexity of this whole workshop?
No, it's not complex. Just the, I mean, even I'm able to follow when Bhavesh is saying.
But on your own, can you do it going forward?
Yeah, some instructions are required first couple of times. If,
Mhm.
whatever Bhavesh is saying, if it is provided as instructions.
Yeah, we have a documentation. Show the
Yeah.
documentation portal,
Okay.
Bhavesh.
So that is
Yes.
one thing. So we can use it for commercial purpose also, right? If you are
Yeah, I
doing
mean,
it
it is
for
Yeah,
meant
you
for
can
that.
deploy
It
it.
is
Yes.
meant for that only.
okay.
So we have very nice documentation if you notice. So
Yeah. We did make a few changes in this workshop from the last workshop. If you notice that this particular file looks different, I think earlier this main.py file used to look like this. Earlier it used to look like this. It had handler and it has do not edit, those sort of things. Now it's reduced. It has been removed and replaced with a hand decorator. So that's why the docs are not completely updated for this particular situation as of now, but for the old method, it is still there though. But yeah, but soon we'll be updating it with like this is particularly 0.5 version. The previous version in our last workshop was 0.4. But yeah, so yeah, but definitely yes, we are going to add a lot more docs and a lot more guides and tutorials for all of this. Primary focus would soon be switched to deployment only.
So Monima and Krishna, this is fully meant for commercial, deployments by companies and developers. So the idea is to try to simplify it as much as possible, so companies and startups can start deploying their AI as an API here. So that's why I was asking you that question. How do you find it? Can you, let's say, you can start using it for deployments of your own AI models in your employer or not?
Sure, we can try that. Okay. It's
Yeah,
simple, but only thing is that something maybe what we can be done without keystrokes, right? That can be avoided, right? So that's what I meant.
Mm-hmm.
So this
Okay.
this cannot be used as a training platform, right? Can we train also here? We saw the example.
Of course,
Training
of course.
this part you can train. The Jupyter Lab is there, right? So you can train it normally here, normally as
Okay.
you would in Colab or any other thing. So normally you can train it and then you can directly deploy it.
Okay.
It's a full AI stack, right? From learn, develop, deploy, train, and so it is full. You can start with
Yeah.
a model. There are already 120 plus bundled projects here. You can pick on any of them, customize them, do incremental machine learning, upload custom data set, custom train it,
Okay.
and then use this deployment scheme to actually deploy it also.
Okay.
Full AI lifecycle is supported.
Okay. So this model can be deployed. So finally, if it has to be deployed on, say, client has got some Azure stack, for example. So this model can be
No, this is
deployed
purely on CellStrat Hub itself.
self. Okay.
I
So
mean, the whole thing is
finally,
This is
customized to
directly
the
applied.
hub
You can use
environment,
this
right?
API endpoint. You can use this API key, and that's it. You don't need to do anything else.
so what I'm saying is typically the client requirement is so we have to propose this CellStrat hub as a this one
Yes.
for. I'm not getting
Yes.
the point actually.
So
Suppose if
Krishna,
we
this is purely everything is in hub. Only
okay.
thing is client can be anywhere else, right? So the client can be your own web app, a mobile app, or any other kind of client. But the
Okay.
AI model and deployed is everything in hub, and hub is on top of AWS. So
Okay.
we cannot support Azure or GCP at the moment.
Okay. Got it.
In future, we might, if we do a multi-cloud architecture. Right now, everything is within the hub, highly customized to this particular environment.
But
Right.
what about security? The typical question will be the confidentiality of
Yeah.
the data,
So
right?
yeah. So data, everything on request, it can be encrypted if you want. So that's all there.
No,
All
I
those
mean, this
features
is
are
core
there if you want
AWS.
to.
Whatever AWS storage is doing, right? So AWS is commercial
Yeah.
grade
Okay.
storage. So, and you have IP of your own model. So whatever coding you are doing here, you continue to have the IP for your own model.
Okay. So it's like developing on AWS, but now we
Yes,
have a MLOps stock also or AI
exactly.
stocks also. Yeah.
Yeah. This is a abstraction over all in general and cloud, so that
Okay.
you can directly do it without going through the cloud.
Okay.
But here you don't need any
And
AWS expertise, right? If you try to do directly on AWS, you have to have AWS expert architects,
yeah.
Mm-hmm.
right? Here you notice there was no cloud expertise needed whatsoever.
Right.
So we are actually doing, boot camps for colleges and enterprises. So if any of your companies need, a specific boot camp just dedicated to your organization, we can do that so that it will accelerate your process on CellStrat Hub. And most of the things are free till you exceed certain quota.
Okay.
Even the 1,000 API calls are free in a month. Okay, so very nice. Bhavesh, what else?
Thanks.
Yeah. So just a final few things that you while developing is that this is a synchronous API. That means in real time that you send a request and immediately get a response. So overall, this has a limit of 29 seconds. So you cannot have a long batch inference as of now. That's in the roadmap, but this particular version is not as of now. So because batch inference requires let's say you have thousands and millions of images and you send that all at once. This particular API won't be able to do that because it will time out in that.
No, but a client
29
can
seconds.
run batch at their end. They can run a batch loop at the client side.
That way they can do. They can run it by one. They can run a batch if they want to. Yeah, that's definitely possible. But if you're like sending all of them in the same request, then that's not possible. As of now, at least.
In future,
And
we'll
all
provide a batch.
the batch inference is there, so definitely there is going to be a batch inference as well. In that case, what you'll actually do is instead of having just username, you'll prepend it with a batch thing. So you'll have something like if you want to run a batch, you'll do batch / and then this. That way, so just doing that will basically turn it into a batch job. So that's asynchronous. So there you send the wave for it later and you come back later after an hour or two to get the results back or something. So that's asynchronicity, but that is but this particular at this particular moment it's all synchronous. And as far as the API being cold, so that is not loaded in memory. So that's why to get it warm, you can make a GET request as demonstrated earlier. So even the web app, when we clicked on the load model button, we are making a GET request to that. And also the source code for the web app is there if you want to integrate or reference how you want to integrate into your existing web apps or applications. And all of the docs, of course, is going to be available in docs.cellstrathub.com. For Workspace, already there's a lot of docs available for the deployment because there's a new feature in beta. We are adding docs one by one. So already for Workspace itself, you do have a lot of things. And I do recommend that everyone do go through the essentials for these things so that you know what are kernels, what are conda environments, how to use the terminal, how to do file management, how to upload, those sort of things. How to run things and zip files and all of those things. And there's also, if you want to integrate your own GitHub account with CellStrat Hub, there's a Git integration page as well. So not just GitHub, but GitLab or whatever, all the general GitLab, GitHub, Bitbucket, those sort of things. And for deployment, yes, this is already there, but we are again going to update it more itself. So.
And how about those packs? So when we add those packs, right? Let's say graph neural networks. So how do I use that? And how do I get the documentation?
In general, so you can only add packs when it's in stock, but I'll just show you. So let's say you get a pack, you get this get pack and click on get free pack, and it's in running state, so I'm not able to add it, but you have to be in stock state. But let's say you add it, it was added. So what you will do is when you start your workspace again, you will see a packs folder. So do you see this packs folder? If you go to that, you'll see all of your packs here. So machine learning, deep, RL, so reinforcement learning, NLP, whatever packs it is there, and you'll find all of the source code there and all of the necessary information to run that.
Okay.
In here itself.
So many of the pack projects can be deployed as API. So you can go ahead and do that and start using the API endpoint key already. So many of the Jumpstart pack projects are eligible to become an API, and you can use it for your own commercial purposes as well.
And if you are in college, for your college projects, it will definitely have, because generally in college projects, we just create the notebook and just have the inference part as separate, right? But if you deploy it with a web app and all, it will definitely fetch for you more marks, right? Even I did it for my own college project. I deployed it on Hub. So those sort of things. So generally you can, if you're on college, you can use Hub API to deploy all your projects and get those extra points, sort of thing. Yeah, so essentially those are the key things that you need to remember. And yeah, I guess
just one more question. So we have the codes, right, for these packs. If we have to understand the subject,
then I guess there's actually courses for that. So the packs are just the projects. If you want to understand all of those topics, then there are CellStrat courses for that. I think Vivek sir can shed some light on that.
okay.
So if you are from a college, which college you are from, Kirtana?
No, I'm not from college.
Okay, so we have individual courses we can provide, right? So you can contact us offline. And if you are from a college, we are doing free crash course, for colleges. For example, currently we are doing crash course for multiple IITs and IIMs, BMS College of Engineering in Bengaluru and Dayanand Sagar, many colleges all across India. So we are doing like boot camps for hundreds of students. So on CellStrat Hub, doing crash courses in MLDL. So we can do that. But if you're an individual, contact us. Let's see how we can work with you. We do have courses in the last few years in Google Classroom.
And another question: can we, if we introduce to startup companies, they may be developing or experimenting some models or product development for their own product development. They can use
Correct.
CellStrat Hub, right? For
Yes, they can.
I mean, you can
as long
launch your
as
own startup here. Krishna, you can launch your AI startup here. And
okay.
you can launch any number of APIs and you will own the IP, and it's just a hosting platform for you. And any
Okay.
startups, yes, absolutely.
Okay.
And later on, we'll provide a kind of a rev share model like an app store, where if you are charging for your API access from your customers, then there will be kind of an app store rev share model.
Okay.
And soon we also have enterprise platform also in the roadmap, where you can have teams. So you can have a central admin account which controls the compute credits for all the sub accounts in the platform or sort of thing.
For example, Accenture has contacted us, right? So Accenture wants a collaborative and competitive coding platform. So we have a demo with them next week, right? So they, for their 200,000 employees in India, they want a collaborative and competitive coding platform for AI. So we are going to do a demo for them. We can do that for any organization for their internal collaboration as well as competitive AI programming. Any other questions, folks? So thank you all.
Also,
Thanks
if
a
you
lot,
have
Bhavesh. Yeah.
one thing, if you have done using this workspace, just make sure you stop your workspace, otherwise it will consume your credit. So just reminding again. So yeah, so if you have done using it, you can just stop it. Yeah, go on, sir. Yes.
Yeah. Thanks a lot, Bhavesh. It's a very good session.
Yeah, thank you everyone for joining. And if you have any other questions or
Thanks a lot.
issues with Hub API deployment, you can definitely contact us offline. And this is Hub API. This feature is still in beta, so we are open to suggestions and improvements and any bugs or anything that you want to report. You can actually find the Google form as well to report any bugs or those sort of things. If you want. And yeah, thank you everyone for joining, and see you in the next deployment session on some other model and some other tricks and tips.
Okay, thank you all. So thanks a lot, Bhavesh. Very well done. As usual, thank you, audience, for joining. We'll see you in our future workshops.